Let's start. Hello, let's start with our today's DSA Journey with this amazing visualizer at DSA.ChaiCode.com. Use this link to get a 7-day free trial. Let's go and into our heap, and today is this one. Okay. So, given an array of points on a plane and a value k, return the k points closest to the origin measured by the Euclidean distance. The answer may be returned in any order. Okay. So if you go to the question in LeetCode, here are given to it. Given an array of points, corresponding point in XYZ plane, XY plane, return the k closest point to the origin. Okay. So let's do it. This one. Okay, so this is our question. K closest point to origin. So using Euclidean distance. Okay, so what is the formula for this Euclidean distance? It is simple. If 2 points are given to us, like in a 2D plane actually in XY, because here given XY plane, and XY is nothing but a 2D plane. So our formula will be this. For a plane XY, points like this one, x1, x1, y1, x2, y2. Okay, so these two are 2 points. So our distance d is nothing but root of x2 minus x1 square plus y2 minus y1 square. Okay. So this is our formula. You can clearly see it here. Now we are given that we have to answer closest to the origin. Okay, so what is the value of the origin? Value of the origin is 0. Okay, so origin, it is nothing but like x1 and y1. So if we put x1 and y1 0 here in the equation, so it will simply give us x2 square, okay, plus y2 square. So this is our final formula. Like if we have to find the distance from the origin, we have to just calculate it. Okay, so does we need to calculate this y? Actually, we don't need to calculate this, not this root. We don't need to calculate root. If we calculate like this one, x square plus y square, so suppose it is d. So suppose we have, if we calculate this also give the same values, because we don't have to calculate the accurate value. Okay, we have to return the k points closest to the origin. So in any cases, if we say, let's take an example, root over of 9 and root over of 25. So take the positive values, not the negative values. To be very honest, don't take the negative values, only positive values. Only positive values. So this is the simple thing. Okay. Also, if we just square both of the area, this will be the same thing. These two, the condition and this condition is true. So if any case, if we found this condition, like if we anyhow we found this 9 or this 25, we can easily tell that which is closest to origin and which is not closest to the origin. So for that reason, we are just taking this, square the value and add the value. Okay, because root can sometimes give us decimal values of double values, where after the point there are multiple values. So we can just easily take this, and just take it only the square value. Okay, so also it is given to here also. No, this give us root. Okay, so in the Euclidean distance, actually the Euclidean distance formula is this one, but for this question we can, if we calculate this one, we can easily satisfy our condition. We have to calculate this one. Okay, so our equation would simply become d equal to x square plus y square. This is the simple formula that we have. This one. We have to make sure that we have to calculate this equation. Okay. So, and every time actually we are given x and y. So if you come here, see, we are given x and y. Okay, and also a value k. So what could be a brute force approach? Okay, I will not quote the brute force approach. The formula will be same. This formula will be same for both brute force and the optimal approach. But I will not quote the brute force approach. Okay. So suppose what we are given to us like this one. 1 3, let's take it like 1 5 8 0 1. So we are given this 4 point. Okay. So calculate this formula for these four values and store somewhere. Okay, so if we do this, take the formula x square plus y square, 1 square plus 3 square 10, 2 minus 2 square plus 2 square like 4 plus 4 8, then 5 square plus 8 square 8 square, it is simply 64 plus 25, it will become 89. Oh, and 0 square plus 1 square, it is simply become 1. So now we are given the points to us, also the distance to us. Now sort the points, sort this, all of these. Okay, sort point based on this simple thing, it's simple distance. Okay, so if we sort it, our condition, our points will be 0 1, then minus 2 2, then 1 3, then 5 8. So this is our point after sorting based on the d value. Okay, based on the d value we have sorted this. Now what is our k? Our k is 2 here, so take the first two element. 2 are actually our answer. So are we given 2 here? No. So if we go, like we see here, we calculate the distance, then we sort it, and we got these two, our two closest value. Okay, so how, like you could take these points are given us as vector of vector, so you can make another vector of vector with this integer, like a pair of vector and integer. Okay, and then just sort it like this. I will just write the pseudocode for it, not the actual code. So our pseudocode would be given, we are given points and key. Okay, now compute d, uh, d square. Actual value is d square, which is nothing but x square plus y square for each points, for each point. Then sort the points by, okay, so we have to sort it by the help of d square. So return the first k points. Simple. Let's evaluate it. We did it. Go write the code by yourself. I will not write this code. This takes big O of in log n time and big O of n space. Yeah. Now goes to the optimal approach. Okay. So what actually we are doing here? We are actually in this brute force approach. We just uh, take the points, take the points, take the points, calculate the distance, sort the points according to the distance. So this is our full process of the approach. Now what we are given to us? We are given a point. We have to return the minimum. And how could we find the minimum? Using this formula. Okay. Using this formula, we could easily find the minimum. So I have written something here. Let me one. So before actually bringing that, I should give you the approach. Okay, first take the approach. The approach is actually same as the previous code. So we are using a Max Heap. Simple. We are using a Max Heap. And what is a Max Heap? A Max Heap is a heap where the parent node value is always greater than its children. Okay, so this would become a Max Heap. Simple. This would become a Max Heap because every parent node value is greater than its children's value. Okay, so we are taking a Max Heap. Simple. And can we, yes, let's do it here. We are taking a Max Heap. Okay, so first insert our value. Simple. Insert our value as we insert. Yes, let's do it here. Then insert the second value. Okay, so now the size of the k heap is 2 and the size and the k is also 2 in this question. Then when we insert our next value, we have to calculate. Like see, in the current position, our root the distance is 10. 3 square plus 1 square. Simply, it's 10. But our current element which we want to insert, the distance is 89. Okay, so we can easily skip it. So it is same as the previous question that we solved. So it is the same as the previous one. So now we can just simply skip it. And the next one is 0, 1. Okay. And our distance is 1. Distance square is 1. And our root distance is 10. So this is 0 square plus 1 square 1. And the root distance is 10. So if we take the root is actually having a bigger value than this one. Okay. So we remove the root and just take it. And at the end, these two are actually the value or the point that we actually need to answer. These two. Okay. This is just the heap property that makes this swap. Okay. So these two are the answer. But why a k? So this one. Simple. Why a maxive? Why a k? Let's go through this one. This sort of text that I actually get. So which point should we remove when we have more than k points? So at any time we can easily reach more than k points. Okay, so we have to remove it from the heap. So which one we have to remove? Logically think that if we have this all of the values, okay, all of these values, suppose so this 10 we insert 10 in the heap. Okay, now this 8 we insert 8 in the heap. Now the heap is a valid heap because it is a max heap, so that value is greater than its children value. So now 89. Okay, so when we insert 89, We just insert it. Now after inserting the 89, the heap will become this one, because this doesn't support the Max Heap property, so it do a swap with the root to support the Max Heap property. Now in this 8, 10 and 89, which point should be removed? Just tell me simply which point should be removed. But first check what we are have to answer. Uh, yes, return the k closest point from the origin, and when we have the closest points, the d value would be minimum. Okay, or the x square plus y square value will become minimum. Then we actually get the value which are closest to the origin. So we just, which point should we remove? Right, because it is the biggest one in this heap, so we have to remove this 89. Okay, so I just take another text. Obviously we should remove the farthest point, and what is the farthest point? It is the biggest point, or the value. Okay, and let's just take it. Therefore we want, and why we take the max if so, we have to remove the farthest point. Okay, the farthest point, and where is the farthest point currently lives? In the root. So we want the point with the largest distance at the top of our heap, because in the heap we can easily remove element from the top. And which heap, which type of heap, let me bring that. Okay. Let me bring this 3 by 1. Okay, delete it. That's exactly a max heap. Okay, in the max heap, the max element is at the top, and we have to remove it from the top. For that reason, we are using a max heap, not a min heap, because our goal is to efficiently remove the farthest point. We are taking the closest point. Okay, or our answer should be the closest point. So how we get the k closest point? We just remove the bigger or the farthest point from this, from this uh, from this distance, and distance formula is this one. Simply this one is our distance formula. But how could we actually store the point and map with that? So in the heap we can easily store like this. So in the heap, every node we will store everything with this d and this xy. Okay, and also the heap will do its automatic work of fixing the to the top with this d. Okay, so now let's write the pseudocode. So our pseudocode is simply take an empty max heap p x and y. Let's take this now, and or first we are given our points and k. Now for every element we just take for every point, for every point from 0 minus 1. First we have to calculate the x, which is our at the x index. It is nothing but points of I, and simply our y would be points of I 1. Okay, because our input is given in this way. So now our target is to calculate d, which is nothing but simply x into x plus y into y. Okay, this one. Now, now we have to push uh, push the d, x and y into the max heap. Simple. Okay, and check this condition, like if the max heap dot size, if any time the size greater than k, then simply pop it. Pop. Uh, let's do it. Max heap dot pop. So just pop it. Now return all, and at the end do a simple thing which is nothing but return all values in max heap. Pseudocode. Let's check it. Yes, we did it. Now this is our point. Let's write down the code. First, first take max heap. And how to take a max heap? Simply priority and this one. Let's take it as PQ, priority queue. And what we actually insert in D and XY. Okay. And also, let me do it. We have to answer our XY together. Okay. And XY is nothing but a vector. So we just simply take pair of int comma vector of int. So we are taking a pair which contain one integer value which is nothing but this d, and one vector which is our points. Simple that. And also we have to take let's take it later. So now loop it for auto point. I just don't take index in points. Okay, so we take every point or every vector from the point, and first take the x is nothing but point of 0. Then simply take the y which is nothing but the point of 1. Now calculate the d or the distance or the d square. I take it as d. It is simply x into x plus y into y. Now push it into the priority. So pq dot push, simply uh, we can just push it like this. Yeah, we can. Actually we can. It is simply d and the point, because point is a vector. So if the pq dot size, if the size is greater than k, then simply do one operation, pq dot pop. So if anytime reach our we reach the greater values, we reach the size of the heap is greater, then simply we just remove the top element, and the top is the maximum element. Okay, so for k is 2, for the value of k is 2, the heap do this pop operation when there are 3 nodes. Okay, and for the k is 2 and we need 2 nodes, and actually we are now having 3 nodes in our heap, so we remove the maximum node so that we can get the minimum nodes, so that we can get the minimum values. At the end disturbance in the house. Now we have the max heap of size k, and we need that k elements into our max heap. So simply this one, take an answer file pq dot empty. So until the pq is empty, this one, until the pq is empty, we just do one thing, answer dot push back pq dot top. So we just take the top element and push it into our answer and simply pop that element. Okay, and at the end return the answer. Simply run it and check it. Error, error. Why? So we need this. I think we need this. Stop. Always, actually, always take the top, not just insert it or push back. Why not push back? The value type is okay. Aha. What is our priority queue value? Pair of integer vector of int. We need this vector of int, and I am in the vector, I am pushing this whole pair. It should be top dot second. So that is the mistake. Careful about data types. Okay, let's be careful with the data types. So the mistake is simple. I was actually having a pair of int and vector of int, and I am inserting only the whole pair into a vector. It will, for that we just take the pair here and then push the second element, which is nothing but a vector, and then pop the whole node from the max. Simple. So this is our question also. Oh yes. Our time complexity would become big O of n log k, and our space complexity will become big O k. So n log k. Why? We are seeing this loop of size n. Okay, and the insertion and the deletion operation, which is nothing but push and pop operation, take log n time complexity in heap. So n log k. And why k? Because at the end we have only k size heap remaining to us. Okay, or we take a k size heap to solve our answer every time, because every time it increases the k, we pop it. For that, our space will become big O of k, or time complexity will become n log k. This is our question, whole question about k closest point. Go check out the question. Use this link. Use this link to get a 7-day free trial. Use this platform at dsa.chaicode.com. Thank you. Thank you very much.